If you're wondering why all this happens, then remember that Kepler didn't know either. He just knew that it did happen because of his studies of the orbits of Mars and the other planets. We'll get to how it works when we learn about Newton.
Let's have a look at Kepler's third law.
Law 3. A planet's period squared is proportional to a cubed.
The period is the amount of time, in Earth years, that a planet takes to orbit the Sun once. The period is measured in Earth years, not days, so the Earth's period is 1 year and not 365 days.
So, like we said, a planet's period squared is equal to a cubed. But what is a?
A is the length of the orbit's semi-major axis. The semi-major axis is half the length of the longest diameter of the ellipse. How's that work? Well, if we draw the longest possible line from one end of an ellipse to the other end, we have the major axis. If we cut that in half, we have the semi-major axis.
The only catch here is that you have to measure the semi-major axis in a unit called AUs. AU stands for astronomical unit. 1 AU is equal to the length of the Earth's semi-major axis. We also use the semi-major axis to measure the Earth's distance from the Sun.
In fact, whenever we measure the distance of an orbit, we measure the semi-major axis in AUs, because that's the easiest way to do it. From now on, if we say that something is so many AUs from the Sun, you know that we're also saying that's the length of the object's semi-major axis.
The long and short of Kepler's third law is that a planet's distance in AUs raised to the third power is equal to the time it takes that planet to orbit the Sun squared.